In this video, we're going to talk about how to convert an octal number into a hexadecimal number. So let's start with this example. Let's say we have 213 in the octal system, that is in the base 8 system. How can we convert it to a number in the base 16 system? Well, first, what we need to do is convert it to a binary number, which is going to be in groups of 3. And then we're going to rearrange the binary number into groups of 4 and then convert it into a hexadecimal number. So let's separate each digit, 2, 1, and 3. And the binary numbers are based on 2's. So I'm going to use 4, 2, 1. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4. So we're going to convert each digit into a binary number. So to get 2, all I need to do is use a 2. So I'm going to replace the 2 with a 1, and the numbers I didn't use, 4 and 1, I'm going to replace it with a 0. So 2 in the binary system corresponds to 0, 1, 0. Now for 1, I only need to use this number. So I didn't use the 4 and 2, so it's going to be 0, 0, and then 1. Now 3, I need to use 2 and 1 because 2 plus 1 adds up to 3. So I didn't use the 4. Let's replace that with a 0. And let's replace 2 and 1 with 1. So 3 as a binary number is 0, 1, 1. Or just 1, 1 as well. Now what we're going to do is we're going to rearrange the binary numbers into groups of 4. So here's the first group of 4. And here is the second group of 4. Now, because there's no 1 here, we could ignore this 0. Now, let's delete this. And let's rewrite the numbers. So we have 1, 0, 0, 0, and also 1, 0, 1, 1. So now let's convert each group of 4 into a number. So the first number corresponds with 2 to the 0, which is 1. The second one corresponds with 2 to the first power, which is 2. And then 2 squared is 4. 2 to the third is 8. Now we have a 1 next to the 8. 1 times 8 is 8. Everything else has a 0, so this whole thing is just 8. Now what about 1, 0, 1, 1 as a binary number? What's the decimal equivalent for that? So let's write the same numbers, 8, 4, 2, 1. So this is going to be 1 times 8, which is 8. 4 times 0 is nothing, so we could ignore that. 1 times 2 is 2. And then 1 times 1 is 1. So we have 8 plus 2 plus 1, which is 11. Now, you need to know that in a hexadecimal system, 10 corresponds to A. 11 as a decimal corresponds to B in the hexadecimal system. 12 corresponds to C. 13 corresponds to D. 14 corresponds to E. And 15 corresponds to F. So since we have 11, we need to replace 11 with B. So we have an 8 and a B. Thus 213 in the octal system corresponds to 8B in the hexadecimal system. So this is our final answer for the problem, 8B. And so that is how you can convert a number from the octal system into the hexadecimal system. Now let's try another example. 331 base 8 into a hexadecimal number. Feel free to pause the video if you want to try it. So let's separate each number into basically 3 parts. So to get 3, we need to add up 2 and 1. So we didn't use the 4, let's replace that with a 0. We've used the 2 and the 1, let's replace it with 1. Now we have another 3, so we're going to use 2 and 1 again to add up to 3. And so we're going to have the same binary equivalent. 0, 1, 1 corresponds to 3. For the last one, it's just a 1, so we only need to use the 1. Since we didn't use the 4 and 2, let's replace that with a 0. And since we've highlighted the 1, let's replace that with a 1. So 331 in 331 in the octal system corresponds to this number in the binary system. So now let's adjust it in groups of 4. So here's the first group of 4, and here is the second group of 4. So I'm going to rewrite that. So this is 1, 1, 0, 1, and then 1, 0, 0, 1. Now let's convert those binary numbers into decimal values. So here we're going to have a 1, a 2, a 4, and an 8. So we have a 1 next to the 8, the 4, and a 1. So we need to add up those numbers. 8 plus 4 is 12. 12 plus 1 is 13. Now here this is 8, 4, 2, 1. So we have a 1 next to the 8 and a 1. So 8 plus 1 is 9. Now 13 corresponds to D in the hexadecimal system. So we have a D and then we have a 9, reading it from left to right. So our final answer is this: 331 in the octal system corresponds to D9 in the hexadecimal system. So this is the answer. Now let's try another example. So this time we're going to use a bigger number, 1657 in the octal system. Go ahead and convert it to a number in the hexadecimal system. So let's separate the 4 digits, 1, 6, 5, 7. And so let's break it up into 4, 2, 1 to convert it into a binary number. So here we just have a 1. So this is going to be 0, 0, 1. 6 is the sum of 4 and 2. So let's replace 4 and 2 with a 1. 5 is the sum of 4 and 1. So let's replace the 4 and the 1 with a 1. And we didn't use the 2, so let's replace that with a 0. And 7 is the sum of all 3 numbers, 4 plus 2 plus 1. So let's replace each of those numbers with a 1. Now, let's break this up into groups of 4. So here's the first group of 4. Here is the second group of 4. And then here is the third group of 4, which works out nicely in this case. So we have 0, 0, 1, 1, and then 1, 0, 1, 0, and then 1, 1, 1, 1. So this is associated with 1, 2, 4, 8. So we have a 1 that's associated with the 2 and the 1. So 2 plus 1 is 3. For the second group of 4 binary numbers, we have a 1 associated with the 8 and the 2. So 8 plus 2 is 10. And then for the last one, every number is associated with 1. So we need to add up 8 plus 4, which is 12, plus 2, that's 14, plus 1, which is 15. Now, 10 corresponds to A in the hexadecimal system, and 15 corresponds to F. So reading it from left to right, we have a 3, we have an A, and we have an F. So we can say that 1657 in the octal system corresponds to 3 A F in the hexadecimal system, base 16. And so this is the answer for the problem. Now to check the answer, let's convert this number into a decimal and this number into a decimal, and let's make sure that we get the same answer. So to convert an octal number into a decimal number, we need to multiply the first one by a to the 0, the second by a to the first, the third by 8 squared, and the fourth by a cubed. So it's going to be 1 times a to the third plus 6 times 8 squared plus 5 times a to the first power plus 7 times a to the 0 power. So 8 to the third power, 8 times 8 times 8, that's 512. Now 8 squared is 64, 64 times 6 is 384. 5 times 8 is 40. 8 to the 0 is 1 times 7, so we get that. So 512 plus 384 plus 40 plus 7 gives us this number, 943 in the base 10 system. So what we're going to do now is we're going to convert the hexadecimal number into a decimal number that is in the base 10 system and see if we get the same answer, 943. So we have 3AF. Now we said A corresponds to 10, but first we're going to multiply F by 16 to the 0 power, A by 16 to the first power, and 3 by 16 squared. So we're going to have 3 times 16 squared, and we can't do A times 16 to the first, but A corresponds to 10, so it's 10 times 16 to the first power. F corresponds to 15, so it's 15 times 16 to the 0 power. Now 16 squared, or 16 times 16, that's 256. 256 times 3 is 768. 10 times 16 is 160. 16 to the 0 power is 1 times 15. That's going to give us 15. And 768 plus 160 plus 15 adds up to 943. And so as you can see, this gives us the same answer, which means that 1657 in the octal system does correspond to 3AF in the hexadecimal system. Thanks for watching.